Okay, let me continue with investment decision rules. We'll go over one section I haven't covered so far, which is the comparison of a small and large project and the incremental cash flow rule. So let me skip all the slides. Okay, we have regular cash flow. So when I mean regular cash flow, so there's no bump, either down or up. So we have here two projects, A and B, okay, one big, one small. So A is big, B is small. So when you look at this example, 15 is 3 times 5 and 9 is 3 times 2. So whatever we do, whatever NPV we calculate, the net present value of A will always be 3 times the net present value of B. So this is good when the net present value of B is positive because you get 3 times a positive number. If the net present value of B is 0, 3 times 0 is 0. But then if the net present value is negative, well, you lose 3 times as much with A than with B. So of course, when B is negative, A is even worse. When B is positive, A is 3 times better. When B is negative, A is 3 times worse. So, but anyway, so when B is negative, A is negative as well. So we don't choose any of these two projects when this happens. This is what I show here. So because 3 times 0 is equal to 0, when the interest rate is such that the NPV of B is equal to 0, the NPV of A is also equal to 0. So both projects will have the same internal rate of return. So here's an example of two projects where A is preferred to be whenever both projects provide positive net present value. So here the NPV rule says pick A over B. Now the internal rate of return rule will say undecided. Okay, so R and B, A and B have the same internal rate of return, and when both projects are negative, well, they're both are negative at the same time. So here so here's the tipping point. Okay, so when the cash flows from one project are a multiple of the cash flows from the other project, then whenever one of them is provides a positive net present value, the big project is necessarily better than the small project. So in other words, if B is a good project, A is 3 times B, so A is 3 times as good. If B is a bad project, well, A is 3 times B. A is 3 times as bad. Now, suppose we take all the cash flows and I reduce them by $2, by 2 units. So A is still 3 times as costly as B, but it does not return 3 times the cash flows. So the sum of the cash flows from A is not equal to 3 times the sum of the cash flows from B anymore, and the net present value of A is not anymore 3 times the net present value of B. So the net present value of A may be larger than B at some point in time for some discount rates, but not for all discount rates greater than 0. So here's an example where it's a good idea to look at the incremental cash flow. Okay, so what we did here, we took a project that had 3 times the cash flows of another smaller project. Now we took the cash inflows and reduced them so that they are not anymore a multiple of the cash inflows from the small project. What do we find? In this case, in this specific example, and you can see it when you look at it, the NPV of A will be larger than the NPV of B for small discount rates. But then, since the project B is less sensitive to the discount rate than project A, the internal return of B will be larger than the internal return of A. So here's an example where the NPV rule and the IRR rule will give you different solutions. How can we deal with that? We will look at the incremental cash flow. Okay, when you use the incremental cash flow method, you ask yourself, okay, if I undertake A and I do not undertake B, how much more do I make by taking on project A rather than taking on project B? So step one, we need to look at how much more costly is it, okay, to start A than B, and how much more in cash flow does A bring me compared to B. Once we have this, we compute the internal rate of return of this incremental project, of the incremental sequence, of the sequence of incremental cash flows. We compare the internal rate of return of the incremental cash flows to the company's cost of capital, and if the internal rate of return is larger than the cost of capital, it's good to forego B in order to take on A. So what do we mean by incremental cash flow? So we consider B or A. Well, B cost $5. Well, A cost $10 more. So compared to B, the cost of choosing A over B is minus 10. Like the cash flow from choosing A over B is minus 10. So choosing A instead of B costs 10 units more. How much more does it bring in period 1? Well, B would bring 3, A brings 7. So choosing A over B means we're going to be making 4 more units in period 1, 4 more units in period 2, 4 more units in period 3, and so on. So A compared to B costs 10 units more and brings 4 more units at the end of the next 5 periods. So A minus B here, that's the incremental cash flow of A over B. Compute the internal rate of return of the sequence of incremental cash flow. So minus 10 plus 4 divided by the internal rate of return times 1 minus 1 over 1 plus IRR to the power 5 must be equal to 0. So that gives an internal rate of return of 28.65%. If we have a cost of capital below 28.65%, it's okay to borrow at 12% in order to finance A instead of B, because financing A instead of B reduces the overall net value of the enterprise when our cost of capital is larger than 28.65. Okay, so this is what the IRR says. So if we had obtained an internal rate of return of 6% with a cost of capital of 12%, well, we borrow at 12%. So whenever we raise money to undertake projects, we have to pay a return of 12% on the amount of money that investors give us. Now, if we choose A over B, and the difference, this decision of selecting A instead of B has an internal rate of return of, say, 6%, well, it's not a good idea. So the choice of A over B is a negative net present value decision, so it reduces the overall value of our enterprise. So this is what graphically what it looks like. So we had A here, the blue line. So 20 is the sum of all the cash flows. So we have 5 times 7, 35 minus 15, 20. 10 is the sum of all of B's cash flows. So 5 times 3, 15 minus 5, 10. A falls faster towards the initial investment than B. Okay, B is less rate sensitive because the size of each cash flow here is much smaller than the size of the cash flows from A. When we compute the internal rate of return of the difference between A and B, we obtain 28.7%. Okay, so that has to be smaller because the two NPV curves cross before the internal rate of return of project A. The internal rate of return of A minus B has to be smaller than the internal rate of return of A, which is smaller than the internal rate of return of project B. So this is an example of how to use and when to use the incremental cash flow method.